Now let's take the next topic, that is similar triangles. Now what do we mean by similar triangles? Two triangles are similar if their corresponding angles are equal and their corresponding sides are proportional. Let us take two triangles ABC and DEF. Now here, if angle A equals angle D, angle B equals angle E, and angle C equals angle F, then we say these two triangles are similar. Or we can say these two triangles are similar if these three corresponding angles are equal to each other. And also we will have AB upon DE equals AC upon DF, which is equal to BC upon EF. These corresponding sides will be proportional. In this case, the ratio will be 1:2. Now, if two triangles are similar, it is not compulsory that they are going to have the same size. Now, why should we study about similar triangles? By similar triangles, we can say if two triangles are similar or not. We can also find the ratio of the areas of two similar triangles. Now, how can we find if two triangles are similar or not? Let's draw two triangles ABC and DEF. Now, two triangles will be similar if they have a pair of corresponding angles which are equal and the sides including that angle should be proportional to each other. These two triangles will be similar by SAS test of similarity. Now the second type is two triangles are similar if all the three corresponding angles are equal to each other. That is, angle A equals angle D, angle B equals angle E, and angle C equals angle F. Then these two triangles will be similar by AAA test of similarity. Now when we are proving by AAA test of similarity, it is enough to prove that two angles are equal, because we know in a triangle sum of all the angles is 180 degrees. So if two angles are equal to each other in the two triangles, then obviously the third angle has to be equal. Now two triangles will be also similar if they have the three pairs of corresponding sides proportional. That is, AB upon DE equals BC upon EF equals AC upon DF, which is equal to half in this case. Then these two triangles will be similar by SSS test of similarity. I hope you have understood this. So we have three tests to test similarity, that is SAS test, AAA test and SSS test. Now let's look at one theorem called the basic proportionality theorem or the proportional division theorem. In this, in a triangle ABC, if a line is drawn parallel to one side of a triangle, that is, say MN is drawn parallel to BC, then this line divides the other two sides proportionately. That is, we have AM upon MB is equal to AN upon NC. This is the basic proportionality theorem. We just need to know basic proportionality theorem. We do not need to know the proof of this theorem. Now we also have one more theorem here, that is theorem on areas of similar triangles. The theorem says the ratio of the areas of two similar triangles is equal to the square of the ratios of the corresponding sides. That is, if we are given two triangles ABC and DEF similar, then the ratio of area of triangle ABC and area of triangle DEF is equal to AB square upon DE square equals BC square upon EF square equals AC square upon DF square. Now the prerequisites for this topic are, you need to know area of a triangle is equal to half base into height. Also, any point on the x-axis at a distance of x units from it will have coordinates as x, 0, and any point on the y-axis at a distance of y units from it will have the coordinates as 0, y. Also, we should know the conversion from meter cube to liter. We have 1 meter cube equals 1000 liters. Now, keeping all this in mind, let's start with the problems based on this topic. We start with the first one, which is quite a simple one. In the adjoining figure, QA and PB are perpendiculars to AB. If AO is equal to 10 centimeter, BO is equal to 6 centimeter and BP is equal to 9 centimeter, find the length of AQ. Now let's solve this. Here we want to find AQ. Now we take the two triangles, we will prove them similar. Once we get them similar, their corresponding sides will be proportional. Using that, we'll be able to find the length of AQ. So we take the two triangles AOQ and BOP. Here, angle A equals angle B equals 90 degrees because we are given QA and PB are the perpendiculars. So we get these two angles as right angles given. Angle AOQ is equal to angle BOP, vertically opposite angles. Now we have proved two angles are equal. So we can say these two triangles are similar by AAA test of similarity. Now when we are doing similarity, it is important the order how we write the name of the triangle. When we were doing congruency, we wrote the order of the triangle in any fashion. It didn't matter. But here, the order how you're going to write the name of the triangle will matter. So we write triangle AOQ is similar to. Now angle A is equal to which angle? Is equal to angle B. So corresponding to angle A, we write angle B. And O is equal to O and Q is equal to P. So we will write the name as triangle AOQ similar to triangle BOP by AAA test of similarity. Now once these two triangles are similar, their corresponding sides are proportional. Now with the help of the name of the triangle itself, we can get the corresponding sides. We take AO upon BO equals AQ upon BP, which is equal to OQ upon OP. Reason for this would be the corresponding sides of similar triangles are proportional. Now let's substitute the values of what is given to us. We are given AO as 10, BO as 6 and AQ we need to find out and BP is equal to 9. Substitute, we have 10 upon 6 is equal to AQ upon 9. Now we cross multiply. AQ is equal to 10 into 9 upon 6. We simplify this to get 15 centimeter. So we have got the length of AQ as 15 centimeter. Now let's look at the next problem. In the figure given, BC parallel to DE, area of triangle ABC is 25 centimeter square and area of trapezium BCED equals 24 centimeter square. DE is 14 centimeter. Calculate the length of BC. We are given the figure. Now, we want to find the length of BC. But first of all, we will prove two triangles similar. In this case, which two triangles can we select? We have triangle ABC and triangle ADE. We take these two triangles. Here, angle A equals angle A, common angle, and also angle ABC equals angle ADE. Because we are given that BC parallel to DE, so the corresponding angles will be equal. Now we have got two angles which are equal. So triangle ABC similar to triangle ADE. Be careful with the order how you are writing the name of the triangle. Now we have got two similar triangles and we know that the ratio of the areas of two similar triangles is equal to the squares of the ratio of their corresponding sides. Now we take the corresponding sides over here as BC and DE because we want to find the length of BC. So we write area of triangle ABC upon area of triangle ADE equals BC square upon DE square. This is because of theorem on areas of similar triangles. Now we can further write this as area of triangle ABC, we know its value, upon area of triangle ABC plus area of quadrilateral BCED, because triangle ADE can be written as the sum of the smaller triangle plus the sum of the trapezium. So we write this equal to BC square upon DE square. Now we substitute the values. 25 upon 25 plus 24 equals BC square upon 14 square. Because we are given area of triangle ABC as 25, area of the trapezium as 24 and the length of DE as 14 centimeter. Now we simplify this. 25 upon 49 equals BC square upon 14 square. That is 25 upon 49 equals BC square upon 196. Cross multiply, we get BC square equals 25 into 196 upon 49. Now we will simplify all this to get BC square as 100. That is BC is equal to root 100, which is equal to plus or minus 10. But BC, it's the length of a side which cannot be negative. So BC is obviously 10 centimeter. Now let's look at the next problem. In triangle ABC, angle CAB equals 90 degrees and AD perpendicular to BC. If AC equals 75 centimeter and AB equals 1 meter, find AD. Now let's draw this figure. We draw a triangle ABC right angled at A. Now we draw from A a perpendicular to BC. That is, angle D is 90 degrees. Now mark AB as 1 meter and AC as 75 centimeter. Now let's start solving the sum. Here we are given AC as 75 centimeters and AB as 1 meter. Now we write this 1 meter in terms of centimeter, that is 100 centimeter. Now we want to find the length of AD. So again, obviously we are going to prove two triangles similar. We take the big triangle BAC and triangle ADC. Here we have angle ADC equals angle BAC, which is equal to 90 degrees. That is given to us. Then we have angle DCA is equal to angle BCA, which is the common angle. So we've got two angles equal, so the triangles are similar. That is, triangle ADC is similar to triangle. Now A is equal to which angle? It's equal to B. And D is equal to A, each 90 degrees. And C is equal to C. So we write the second triangle as triangle BAC. That is, we have triangle ADC similar to triangle BAC by AAA test of similarity. Now we will write the corresponding sides which are proportional. We have AD upon BA equals DC upon AC, which is equal to AC upon BC, since the corresponding sides of similar triangles are proportional. Now out of these values, we know the length of BA and the length of AC. We need to find the length of AD. Now we do not know the value of DC or BC, but the length of BC can be found out by using Pythagoras Theorem. We have the right angle triangle ABC and we know two sides of the triangle. So we can find out the hypotenuse BC by Pythagoras Theorem. We write this as BC square equals AB square plus AC square. We write this as BC square is equal to 100 square plus 75 square. That is 10,000 plus, now what is 75 square? That will give us 5625. So we have BC square is equal to 15,625. So BC will be root of this number. Now what is the root of this number? We can look into the square root table, that is the log tables. We will get 125. So we have BC as plus or minus 125, but obviously BC cannot be negative, so BC is equal to 125. Now we substitute this value of BC in the statement 4. We get AD upon 100 is equal to 75 upon 125. Cross multiply, AD is equal to 75 into 100 upon 125. We simplify this to get 60 centimeter. So we have the length of AD as 60 centimeter.